Welcome to ClickMyProject.com. Now we are going to discuss about the project rice grain classification using multi-class support vector machine. Now we are going to discuss about the abstract of the process. The main purpose of this project is to present an image processing based on the solution to classify the different varieties of the rice grain based on the images. An approach based on the combination of features, extractions and classification method. These two methods plays a vital role in this project. Variety of rice grain is determined by morphological features such as the HSV, mean standard deviation and variance of the rice grains. The dataset consists of the different kinds of the rice grain varieties. So we have to choose any one image from the dataset. Based on that selections, the classification will be done by comparing the sample images with the database images. Hence, the SVM is used to detect the type of the rice grain. Then the classifier performance will be evaluated based on the accuracy, sensitivity and specificity. Based on these three parameters, we can justify our process as good. Based on the accuracy, if the accuracy is above the 95 to 90% in the sense, it will having the good performance of the classification. Now we are going to discuss about the flow diagram of the process. This is the overall working flow of this project. The project consists of the modules such as dataset, input image, then pre-processing, feature extraction, classification and finally performance estimations. At first, the input rice grain image is taken from the dataset. The dataset image consists of the lots of grains such as the three kinds of images will be there. After taking any one image from the dataset, the pre-processing will be carried out. In this pre-processing, grayscale conversion is carried out and then the noise filtering and resize will be carried out. So grayscale is the main color conversions, which is converted the RGB image into the grayscale images. Then the resize is carried out to maintain the aspect ratios of the images based on the number of row and number of column of the images. After doing the pre-processing, the feature extraction is carried out by means of the three kinds of the parameters, which is the mean, standard deviation and variance. Based on these three parameters, we can extract the features from the images. After doing the feature extraction, the classification is performed by means of the support vector machine. Here we are using the multi-class support vector machine to classify the three different kinds of the rice grains. After classifying these three things, we have to perform the performance estimation of the project. So the performance estimation is based on the accuracy, sensitivity and specificity. Based on these three parameters, we can justify our process is efficient or not. In case the accuracy is above the 90 to 95% in the sense, the accuracy of the classification is good. So these are the overall performance of the project. Now we are going to discuss about the running procedure of the project. At first, open the Spider 3.7. After that, you have to change the working directory to execute the project. Now you have to open the mainfile.py. This is the executable file. After opening the mainfile.py file, you have to click the button run. After selecting the button run, we have to open the dataset folder. In that dataset folder, we have three kinds of rice images is there. Among that, we have to select any one image from the dataset. The selected image will be shown in the console. The process will be done one by one in the console window. Now we can see the results one by one. This is the original image, that is the input image which we have taken from the users. After getting the input image from the dataset, the corresponding image is shown in the console. Then the pre-processing will be carried out. In this pre-processing, we have two stages of pre-processing. So first thing is the image resize. Then the second thing is the image should be transferred into channel separation. First image resize is done to resizing the row and column of the image. So here the row and column of the image is around 24 in the the size of row and column. After doing that, we have to separate the channels for red, then green, then blue, like this. After segregating the channels from the image, we just convert the image into a grayscale format. Now the input image is the RGB image. Now the grayscale image consists of only the single band. After doing the pre-processing, we just move to the third stage of the process, that is the segmentation. In the segmentation, the background pixel is completely eliminated and this fixed by the black color. Now the foreground pixel is extracted, that is the binary image of white colors. After doing the segmentation, we have to extract the features from the images based on the deep learning method by means of the convolutional neural network. Before that, the data will be splitted into an 80% and 20% ratio, which means the test data will be the 20% and then the trained data will be the 80%. After that, we just applying the convolutional neural network and then the local binary pattern to extract the features from the images. After doing the extraction of the features, the collected features is stored as an test feature. After extracting the test feature, during the classification, test feature, train feature and labels will be matched together by means of the classification machine learning. After doing this one, the recognized rise type is displayed here. Finally, the classification accuracy will be displayed here. Thanks for watching this video.